Hey everyone, did you miss my drawings? Because today we are going to make chess in Java. This project is simple but robust enough to be your first game from scratch, especially if you don't know how to get started. However, this will not be a tutorial, but a launching point. While I will go over some of my code, I want to show you the principles and thought processes behind starting this kind of project, but I want you to learn how to style, debug, and organize software projects on your own. So first, why Java? Well, it's a great starting language to learn object-oriented programming without some of that messy stuff like memory management. And why chess? Well, it's a game that's familiar to everyone, simple enough to complete on your own, and you will learn principles important to engineering, not just game development. Platformers and other common starting projects deal with physics and frames and tools like Unity that might take a long time to learn. But chess, it's basically entirely programming logic. You choose a piece, you move it to a square, you don't have to worry about animations or graphics, and you could expand it to your own game. You'll see this later on that if you design something well, you could expand your chessboard to like a 500 by 500 board, and it could be the basis for a real-time strategy game or your own board game. So I highly encourage you guys to get creative and use this as a launching point for your first game projects. Object-oriented programming means that you separate the project into different components called objects, which are organized into classes. You could have the board, the player, the pieces, and this is where you can get creative with how you design these different classes. For example, the player class might contain a color like white or black for the pieces they control, or a score for how many pieces they've captured or games they've won. But this can vary so much depending on your choices. The pieces are best described by a concept called inheritance, meaning they all have similar features in common with one another, but they behave differently. So for example, if we think of some things that pieces have in common, they can all capture other pieces, they can be captured, they have some kind of type like bishop or knight, and they have movement. So the knight has a movement function, but it's going to be implemented differently than the pawn. And this is where we can have a generic piece class and have them all inherit from that class. And I can show you this in my code right after this. Just remember that there are infinitely many ways to design a game of chess, both good and bad. Remember that it's better to break things up into many classes and functions rather than have one class or function do everything. Today, we're going to focus on the pieces, and I'll show you how I did it a couple years ago. Alright, so I was skimming this earlier and I found a lot of things I wanted to change, but I think we can just go through this together and see areas that can be improved. I think it's actually better to show code that is real and maybe isn't perfect, because that's how all code is. No one is a genius. No one writes perfect code. And it's kind of like writing an essay or something. You can always improve on it later, especially when you come back with maybe a more mature mindset. You're more mature at programming. So right off the bat, let's talk about this generic piece class. What is this abstract? Well, abstract in Java means that we can't instantiate it, meaning we can put bishops and knights on the board, but we can't just have a generic piece. And a class is abstract when you have abstract functions in it. So for example, this one's simple, public abstract get type. So a generic piece doesn't have a type, right? And type just returns whether it's a bishop or a king or a knight, but this doesn't have a type. So we can't instantiate something that's typeless or entire game breaks. That's the same thing with movement. It has no movement implemented, so we can't instantiate. However, it makes a really nice interface to organize the rest of our pieces. And you see, if you're looking at my hierarchy, I have some weird looking pieces called like a princess and a zergling, and it's having this inheritance hierarchy structure that allows me to add new and weird pieces. I'm not just limited to the standard chess roster. Okay, so now we have some idea of what abstract is. Once again, this is just giving you an overview. I highly recommend looking things up on Stack Overflow. Google is your friend. I would say so many programmers do so much of their work just by well thought out Google searches. The first thing I see that I'm not a fan of is I think we should identify our member variables. And this is one code standard. It doesn't look as pretty, but you know, we'll just do this for now. So basically I'm putting an M in front of all the member variables. And this is because if you see here, I had to specify this dot x equals the x in the parameter. This is the constructor. But instead, it's a lot more elegant if they don't shadow each other, if they don't, if the input is not the same name as the member variable. Because now instead of using this, we can just say mplayer, mx, my, and it makes sense because they're member variables. So this is our constructor. I'm glad this is kind of the standard way to do comments, and I highly recommend commenting your code. Even if it's so redundant, even if this is completely obvious, it really helps, especially if other people are going to work on it. You want every function and class commented. I know that sounds like overkill, but it has helped me so much. Like looking at this a year later, I know exactly what's going on, and I'm serious. Before recording, I only looked at this for about 5 minutes and I remembered exactly what I was doing. I can't say that for most of my other projects that I kind of just tried to rush and get done. Now the next thing I'm looking at are these brackets. See how my brackets are not consistent? Now personally, I like doing my brackets this way. IntelliJ, which by the way, I'm using IntelliJ and I highly recommend it. If you're a student, you can get the Ultimate Edition for free. I am using the Ultimate Edition. I have been using it for like every project, web development, Python, data analysis, the games like this. IntelliJ is awesome, but IntelliJ automatically does this. But I like it like that. Don't ask why. It just makes me feel more comfortable. Do we have any other brackets in here? No, but that's okay. The next thing is, see how this looks kind of ugly here? This might be a bad example of object-oriented programming. And you can judge that for yourself as you start implementing your game, how you want to store your pieces and their locations. In my case, I have a player associated with a game, and then a game has a game board, and a game board has the board array with all the pieces. Now, right off the top of my head, I'm thinking it makes total sense for a game board to have the pieces. I think that makes sense. But having the player associated with the game, perhaps it should be the other way around. I don't know. You guys can decide. That's one of those design choices I was talking about. What should contain what? How should things interact with and access each other, right? All right, so let's just move down. The rest of these are abstract functions, meaning that, once again, they have to be implemented by these pieces for the pieces to be usable. And so we have one is valid path, and I believe that's when the user clicks on a piece and then they click on a square, it will tell the user if they've clicked on a square that isn't valid. Like if you tried to take a knight and then just move it straight across the board like a rook, it will tell you you can't do that. So that's what this function does. And then we have draw path, which basically lays out the path that the piece is going to follow based on where the user has clicked. See, it takes a starting destination, a starting point and a destination. It draws out that path. It determines like if you're a knight, if you're leaping over something, if you're landing on a piece, if you can capture it, things like that. And one thing I've noticed here is that instead of having two ints making up a start X and a start Y, I should probably make some kind of pair class or use pairs. so that it just takes 2 inputs. Maybe it would just be like pair start, pair finish. That's another thing to think about. And then type, get type. I made a enum right here of types. It has its own class, and this is all it says. It's just the list of types. If you don't know what enums are, look them up because they're really useful in a project like this. But now let's look at an actual piece. So let's look at the bishop, just the first one. And now we have to change some things because yeah, this code probably won't function because I changed these up here. We can refactor this using the amazing refactor tools in IntelliJ, but let's not worry about it for right now. So let's take a look at the bishop. So we have class bishop extends piece, meaning it's inheriting from the piece. So it contains a type, which we'll set to bishop. See in the constructor here, it just takes a position, the player it belongs to, and then its type is set to bishop automatically because this is the bishop class. Now, I believe I have the player associated with a color, but you could also have the bishop have a type and a color, or the color could be included with the type. That's another choice. And this super means that it calls the constructor of the generic piece, and then this is all we have to do in addition to the generic piece constructor. So you can see we're writing fewer lines of code by having that piece class as what we're inheriting from. And then return type.bishop. This is pretty straightforward. Let's see. This is where it gets more interesting. So is valid path, it's determining whether the bishop is moving diagonally. So it's taking the difference between the x's and the y's. And if you think about a diagonal line, if you're moving up 3 and over 3, the difference between the x's and the y's will be the same, the absolute difference. So that's actually pretty simple to determine if it's moving diagonally. But then if we actually want to draw the path it's trying to take, it's a little bit more complicated, but it's not too bad. So first, we're deciding which direction we're going in. Are we going to the left or the right? Are we going up the board or down the board? So we set these signs in the x direction and y direction to figure out which way we're going, and then we draw the path by diagonals. If this is difficult to understand at a first look, try getting out a piece of paper and just drawing out this code and seeing if it works or not. If it doesn't, great, let me know. I have bugs, that's fine. But if it does, you can kind of see how this would draw the path for a bishop. Now you can see how I've organized things into different packages, which once again, recommended. Organize things, divide them up, classify them as much as possible. And these are some classes you might want to implement, but you could do things completely differently from me. The last thing that I want you guys to take a look at are unit tests. This is so important to get in the habit of testing because you want to make sure your code works perfectly before you move on. You want to be able to work on a small portion of it, test it, know that it works to perfection, and then build new modules on top of that. That's another great habit to get into as a programmer. Otherwise, it's so difficult to debug. And maybe you change something way down the line, and if your tests fail, you can go back and easily find bugs. So unit tests, it basically means that you just want to test for one thing at a time per test. So for example, we're testing that it's moving down and left properly, that it can move up and right, can move down and right, it can move up and left. We're testing that it'll say something's invalid if it tries to do an invalid movement. We're testing that it successfully captures pieces, that it can't be moved on top of a friendly piece, and you know, every single edge case you can think of. This is so ridiculously important. Do tests for each of your pieces, especially, this is one last thing, checkmate and detecting checkmate can be so difficult. This was kind of a nightmare to code, but it's something that you also want to thoroughly test. You have to look up situations where pieces are in checkmate and test that all of those board combinations work with whatever code you have to check for checkmate. Anyway, guys, that's all I have to say for now. If you have questions, definitely let me know. I'll try to answer them, but hopefully this gave you some idea of how to get started, and I really hope you guys turn this into something even more than just chess. You could even try to port this into an app. You can do so much. So anyway, guys, thanks so much for watching. I'll see you guys next time. Bye.